Hey everybody, my name is Chris and I'm a tutor here at Chegg.com. I mostly do math and computer science, and in this video we're going to find the volume of a solid using cross-sectional areas. So here we have the base of a solid is bounded by y equals x squared, y equals 0, and x equals 1, and we want to find the volume of the solid if the cross-sections taken perpendicular to the x-axis are squares. So if you're relatively new to this sort of thing, or even if you're not, this might be hard to visualize. So let's go ahead and draw a graph of what's happening. So let's go ahead and put, there's our y-axis, there is our x-axis, x-axis, y-axis. So here is y equals x squared, and then y equals 0 is just the x-axis, and then x equals, so this is y equals x squared. And then x equals 1 is this vertical line here, we'll say. Right, and yes, y equals x squared continues off in the other direction, but we don't really care. We only care about the base of the solid, which is this shaded area in here. That's the base of our solid. Okay? Now, what is the, before we move any further with this, what is the formula for the volume using cross-sectional areas? In general, the volume V is the integral from a to b of a, capital A of x dx, where capital A of x represents the cross-sectional area at x units. Okay? So in our case, we have the integral from what? Well, we're looking at this region here. Here's our base. We're going to integrate in the x direction. Okay, so that's going to be from 0 to 1. So the integral from 0 to 1 of what? Well, a of x represents the area of the cross-section at x units, and we're told that the cross-section is taken perpendicular to the x-axis, which means this direction, okay, perpendicular to the x-axis. Those cross-sections are squares. And if they're squares, well, first of all, what's a cross-section of the solid look like? Well, this here, this entire shaded area is the base, so if we take a cross-section of the solid here, this is going to be the base of our cross-section. Right? And what is the height of this here? Well, here, since this is 0 down here, okay, this, what I should say is this is y equals 0 down here. So down here is y equals 0. And up here is what? Up here is y equals x squared because it's on the function y equals x squared, right? So up here is x squared, down here is 0. So the height then, or really the length I should say there, is x squared minus 0, which is just x squared. So when we take a cross-section of our little solid here, this is the base of the cross-section, and the length of this base is x squared. Well, we're also told that the cross-sections themselves are actual squares. So if the cross-sections are squares, and we know the length of one side, how do we get the area? Well, the area is a of x equals x squared squared, right? Because x squared is, that says is the length, is the length of one side of the cross-section, and I'm out of room down here, but and the cross-sections are squares. So if we know that they're squares and we have the length of one side, we're just going to square the length of that side to get the actual cross-sectional area. Okay? So then a of x is just x to the fourth, because x squared squared is x to the fourth, right? dx. Okay, so again, the cross-sectional areas are squares, and we know that the length of the base of the cross-sectional area is x squared. Therefore, x squared times x squared is x to the fourth, and that gives us our cross-sectional area. So from here, it's just a matter of integrating. So if we integrate x to the fourth, we get 1/5 x to the fifth, and we're evaluating from 0 to 1. So this is just 1/5 times 1 to the fifth minus 0 to the fifth. 1 to the fifth is 1, 0 to the fifth is 0, so this entire thing is just 1/5. Okay, so this has been an example of using cross-sectional areas to find a volume, and I hope you found this video helpful, and thank you for watching.